Okay, let's take a look at this lesson. We're going to look at trig substitution. Now, if trig is one of your strengths, you're going to love this lesson. If it is not one of your strengths, you probably won't love the lesson, but it is really trig heavy. Of course, it's trig substitution. We use this technique when one of our other techniques won't work. It takes a little while. And so this is after we try some of the other things that we've worked with, we work on this, we use this technique. Actually have narrowed it down. We're just looking at trig substitution. We're not looking at the other technique because we've already looked at completing the square. We do that in a different lesson. So we're just looking at trig substitution. The general guidelines that you need to use are here. If you don't remember these, then you're going to be kind of just running around in the dark. If you don't remember where to start, you're just going to try different things and it will take you longer. So it would be really important to remember, and let me explain what this is. If you have, basically what this is good for is if I set, in this first instance, so number 1, if I set x equal to sine, then what I'm able to do, if I have something in my integrand like this, a number minus x squared, and if I set x equal to sine, I'm able to do 1 minus sine squared, and we know 1 minus sine squared is cosine squared. It's especially helpful if it's under a radical, because the square root of cosine squared would be cosine. It helps us eliminate radicals. That's when it is especially helpful. So if you have this part in your integrand, it's set up like a squared minus x squared, then you're going to want to do the sub sine for x. And I've got a couple of examples to show you, so we'll look at that in just a moment. If you have like an a squared plus x squared set up in your integral, then you would want to make x tangent, because 1 plus tangent x is secant x. We would replace that with secant squared x. And the last option is if you have like an x squared minus a squared, then you would make x secant. So you'd have a secant squared minus 1. So really the trig functions that you want to be using for substitution are either sine, tangent, or secant, period. Those three. If you don't remember which one to try, it'll be much longer. So you really should kind of remember which one to try. So that's the setup of it. Let's do some examples, and then hopefully it will make sense. All right. Let's take a look at our first problem. On this, we have, let's see, we have like a number minus x squared. Okay, so we look to our little patterns and we want to see which one does the number minus x squared, and that's the sine. Now what's really important is I need it to be 1 minus sine squared, not 4 minus sine squared. So instead of making x just sine, I need to make it a number sine so that I can factor the 4 out. So if I make x 2 sine theta. Now, notice how I'm changing the variable. There's a reason that I'm doing that. It's what we're doing is we're substituting. We're not really, if you use an x here, you could get confused and think that we're in the same variable that we started in, and we're not. This is like a substitution. It's like a u substitution, but it's not u. It's like we're using theta. If you don't like theta, you could use alpha, or whatever. Just don't use an x for your substitution. Use something else. So if we make x 2 sine theta, then when I put it in here for x squared, it's going to be 4 sine squared, which I'm going to be able to factor the 4 out. Y'all see that? Okay. So just like on u substitution, I do that and then I do the derivative. So dx equals, so the derivative of 2 sine would be 2 cosine theta d theta. And that's my first step. At this point, what I'm going to do is I'm going to substitute these guys in everywhere in here. All the x's are going to have to disappear. The dx is going to go away, the x squared, everything has got to be replaced with this combo over here. So let's rewrite And these problems need just a little bit of room. You know, they take a little bit of room to work. So let's rewrite. We're going to replace the dx. Dx is this expression, 2 cosine theta d theta. So that's what we're going to replace it with, 2 cosine theta d theta. The x squared on the bottom, let's kind of think about this. If x is 2 sine theta, then x squared, we would square that. We would get 4 sine squared. 4 sine squared theta. Underneath the radical, we have 4 minus. Then our x squared again, we have already talked about that. That should be 4 sine squared theta. And all of the x's and dx's have been eliminated. I'm only in theta. Okay. So my next part is lots of manipulating, lots of algebra, lots of working with this to get it as simplified as possible before we try to integrate it. So this, the 4 minus 4 sine squared, I would factor a 4 out. We've looked at this kind of concept before. It's an exponential concept where I have like a 4 times 1 minus sine squared, and I can do them separately, like square root of 4 times square root of 1 minus sine squared. It's an one of those concepts. I'm going to go ahead, this 2/4, I'm going to reduce it, and I'm going to bring it out front to 1/2 the cosine theta. He's still up there. In the bottom, I have the sine squared theta. Now this, I'm going to, hopefully this isn't going to disturb anyone. I'm going to go ahead and factor the 4 out and bring it all the way out. It's going to be square root of 4, which is 2. Okay, I'm going to go ahead and just bring that out. What's left under is 1 minus sine squared theta. Okay, so I did a couple of steps in one. Is everybody okay with that? Okay. This 2, in my next step, I'm going to bring it out. And I'm showing probably more steps than I would normally, just so that you can see what's going on. You don't have to show all of the steps that I'm showing. So I would bring the 2 out to be a 4th, and 1 minus sine squared, we know in trig is cosine squared. So we have 1/4 integral of cosine theta d theta. Here in the denominator I have a sine squared theta, and then the square root of cosine squared theta. Now hopefully we can see I'm going to simplify that cosine squared theta because it's under the radical. It's going to turn into just cosine theta. So 1/4 integral of cosine theta d theta over sine squared theta cosine theta. Okay. As I said, I'm showing quite a few steps just so you can see what's going on. You can skip many of these steps. Okay. So at this point, we can see that the cosines cancel, and I'm left with 1/4 integral of 1 over sine squared theta d theta. And we can't integrate 1 over sine squared, but we can change it, right? This is like all kind of trig. Everything trig you know you're going to be using in this lesson. So 1 over sine squared is the same as what? Yep, cosecant squared. So 1/4 integral of cosecant squared d theta. If we were going to be taking the derivative of a trig function and get cosecant squared, what would it have been? Yeah, negative cotangent. Because remember, if we took the derivative of tangent, cotangent would be a negative cosecant. So negative 1/4 cotangent theta plus c. Now I'm sure we're kind of excited. It's kind of a big process, but hope not to disappoint you, but we are not done. I know we can't leave it in theta. Just like when we did u substitution, we couldn't leave it in u. We actually have to take it out of theta. And the way that we do this, okay, it's kind of cool. It's a trig way. We're going to do a triangle. We miss doing those, don't we? Okay, yes, we do. I'm sure we do. We're going to do a triangle. And usually I do this at the first of the problem. I didn't want to scare you by doing it at the first of the problem, but I usually do it when I do this setup up here. I solve for sine theta in my original expression. So sine theta equals x over 2. And I put that representation on this triangle. So if sine theta is x over 2, and we know that sine is opposite over hypotenuse, so opposite would be x, hypotenuse would be 2. I would do Pythag, the Pythagorean theorem, to get this other piece, which everybody in here should be able to do. That's square root of 4 minus x squared. And what I'm going to do is I'm going to use this representation here to translate my theta. I want to get it out of theta. So this is going to equal negative 1/4. So we're going to read cotangent off of our triangle. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. So it is the square root of 4 minus x squared over x plus c. And I mean, we can just pretty it up just a little bit. Not very much. Just negative square root of 4 minus x squared over 4x plus c. And now we're done. Yes? I just use Pythag. So x squared plus, we don't know what it is, squared equals 2 squared. You know? This, I got it from my original substitution. I have to solve for whatever trig function I'm using. No. I got it out of my trig substitution. Yeah, I got it out of my trig substitution. Yes. Why do I set x equal to 2 sine theta? Because I have an integral in the form of a squared that has an a squared minus x squared in it. And that's what our guideline is on the other slide. If we have one in that form with a number minus a variable squared, then that's the trig function we should use. Okay, I'm not sure I'm understanding your question. This we want it to turn into 1 minus sine squared, so we can turn it to cosine squared. That's why we use sine. Okay? Other questions? All right, let's do the next one. We have one more. And I need just a little bit of room here, so where are we? There we are. Okay. All right, now we have one that has an x squared plus a number. Which one should we use? Tangent. We're going to use tangent. So we're going to let x equals tangent theta. Again, we determine that substitution from the first slide that gives us our guidelines. If you don't remember the guidelines, you're just going to be kind of struggling about which one to use. So dx is going to be secant squared theta d theta. Okay. I'm going to go ahead and do the triangle thing. I mean, we know we're going to have it, and that's what I normally do. Just go ahead and work the triangle. Might as well. Put all of the information in one place that you're going to need to do your substitution and then your translation back. So we already are solved for a trig function. We're already solved for tangent. So tangent is opposite over adjacent. So x opposite over adjacent, which is 1. We do Pythag to get the other side. And we get square root of x squared plus 1. Okay, so this is all the information that you're going to need to be able to do the problem. And I just usually put it in one place. Alright, so let's do our substitutions. dx is secant squared over, then our x squared, our x is tangent, so tangent squared theta plus 1 to the 3/2. And we know our Pythagorean identities, so tangent squared plus 1 is secant squared. So secant squared theta d theta over secant squared theta to the 3/2. Now let's talk about the 3/2. That was troubling some people earlier today. I'm going to write it in exponential notation, so perhaps that will make more sense. It's all going to be exponential. So secant, this is just like a side note. I'll just write it over here. This can also be written as secant squared, right? That part, right? Secant squared. I'm raising that to the 3/2 power. So when I simplify that, the radical is gone, right? The 2's cancel. And I'm simply left with, so if you look at this, 2 times 3/2 is, 3. So this is going to be secant cubed on the bottom. It simplifies to secant cubed. So we have integral of secant squared theta d theta. And on the bottom, it simplifies to secant cubed theta d theta. Okay? So we simplify that. Oops, I have extra one. There we go. So simplifying that, we have a squared on top and a cubed on the bottom, so that leaves us d theta over secant theta. Oops. Which we can't integrate 1 over secant, but what can we change that to? Cosine. We can change this to integral of cosine theta d theta, and we know how to do that. The integral of cosine is sine, so sine theta plus c. Are we done? No. We have to put the x's back in, so we use our triangle. We read sine off of our triangle. So we have opposite over hypotenuse. So x over square root of x squared plus 1 plus c. Okay? How's that? Questions? There are some on the daily work are a little bit more complicated than the answers are, and there requires a little bit of simplification, but nothing major. Nothing major. Okay? All right, great. Oops. Okay.